June 1941, a British infantry company near Salem, Egypt, watches 6 German Panzer III tanks roll toward their position. The lieutenant orders his anti-tank rifle team forward, 2 men lugging a 55 lb boy rifle that could supposedly punch through armor. They set up, aim at the lead tank's hull at 200 yards and fire. The half-inch tungsten round hits dead center. It leaves a fist-sized dent and ricochets into the sand. The Panzer doesn't even slow down. 4 minutes later, that entire company is either dead or running. This wasn't an isolated incident. This was the standard experience for Allied infantrymen. From 1939 through early 1942, German armor engineering had leapfrogged everything the Allies could carry into battle. The Panzer III came with 50 mm front armor. The Panzer IV had 80. The Tiger I's, which started appearing in late 1942, rolled into combat with a 100 mm hardened steel protecting its crew. And Allied foot soldiers had effectively nothing that could stop them. Let's talk about what they did have. The boy's anti-tank rifle, Britain's main answer to armored vehicles, could penetrate 21 mm of armor at 100 yards under perfect conditions. Perfect conditions meant flat angle, no sloping, the right type of steel. Combat conditions were never perfect. The rifle weighed as much as 2 men's full kit, kicked hard enough to break collarbones, and required 2 soldiers to operate. Most importantly, it couldn't reliably stop anything heavier than a light armored car. By 1941, the Americans had it worse. When the U.S. Army entered the war, their anti-tank rifle was the .50 caliber M2 Browning machine gun. This was the same gun mounted on half-tracks and aircraft. Against a moving Panzer IV, it was about as effective as throwing rocks. Some infantry units carried sticky bombs, devices you were supposed to run up and attach to a tank by hand. The survival rate for soldiers attempting this maneuver was roughly what you'd expect for someone sprinting toward a 30-ton machine gun platform. The British tried the Pat Projector infantry anti-tank, which launched a 2 lb bomb using a massive spring. It had an effective range of about 100 yards, required 40 lb of force to, and frequently failed to penetrate even when it hit. One British sergeant in North Africa described it as a drain pipe loaded with hope. The French had the Brandt ML1935 grenade launcher. The Soviets used anti-tank grenades that required soldiers to close within throwing distance 20 to 30 yards from machines bristling with machine guns. Here's what made this situation genuinely terrifying for Allied commanders. Armor doctrine was changing. German tactical philosophy by 1941 centered on combined arms, tanks supported by infantry and artillery all moving together. When a panzer division attacked your position, you couldn't just hide and wait for your own tanks to show up. Your own tanks were probably burning 3 miles back. You needed something a 19-year-old infantryman could carry, aim, and fire before that panzer's machine gunner cut him in half. Something that would actually penetrate the armor and stop the tank. By late 1941, after watching entire divisions crumble under German armored assaults in France, North Africa, and the Soviet Union, Allied war departments were receiving the same desperate message from every theater. Give us something portable that kills tanks or we're going to lose this war, one shattered infantry company at a time. The casualty reports made the math brutally clear. During the Battle of France in 1940, German armor shredded Allied defensive lines specifically because foot soldiers had no effective answer to tanks. The problem wasn't tactics or courage. The problem was physics. Infantrymen were bringing 20 penetration to an 80 armor fight. And that's the situation facing U.S. Army ordnance in early 1942. Fix this problem fast or start explaining to families why their sons died helpless against machines they couldn't scratch. The solution arrived in the form of 2 Army officers standing in a Maryland workshop with a piece of pipe and a terrible idea. Captain Leslie Skinner had spent months working on a handheld rocket grenade, a small explosive projected by a solid fuel motor that a soldier could theoretically throw farther than his arm allowed. The prototype worked barely, but the rocket motor's back blast was enough to blow off the thrower's hand. Not ideal. Lieutenant Edward Oule watched one of Skinner's test rockets fly and asked the obvious question, what if we don't throw it? What if we just launch it from a tube? Skinner looked at him like he'd suggested building a cannon out of cardboard. Then they did the math. A simple steel tube open at both ends would let the rocket motor's exhaust vent backward while the projectile flew forward. The operator would stand behind the tube, aim, fire, and if everything worked, stay alive. They tested the first prototype in May 1942 at the Aberdeen Proving Ground in Maryland. Poole grabbed a piece of pipe from a scrap heap, measured it to match the rocket diameter, and sealed one end with a wooden plug that had a small hole for the electrical firing wire. They mounted it on a crude shoulder stock made from wood and metal fittings. The entire assembly looked like something a mechanic welded together during lunch break, because that's essentially what it was. The first test shot went 60 yards and hit within 10 ft of the aiming point. The second shot went 50 yards and veered 15 ft left. The third shot tumbled end over end and landed 45